No, sorry, you tell me. Okay. Assalamu alaikum everyone. Today we're going to be going over functions 11. Okay. So I'm just going to make a new notebook for our notes. Okay, and my student here is Aisha, and she is going to basically be our live student here. Live examination. Okay, Aisha, so let's get started. Bismillah. And today we're going to, so lesson number 1. Okay, so I'm just gonna, I'm not sharing my screen. No, don't sit on your computer, move your stuff away. No mishaps. Share my screen. Start now. Okay. So can you see my note shelf? Yeah. Yeah, okay. Good. Okay, so let's start. So lesson number 1 is reviewing functions. Okay, so you must be wondering what is a function. So okay, so in today's lesson, we'll be examining some of the functions you have already encountered in grades 9 to 11, both graphically and algebraically. So recall that a function is increasing if it rises upwards as scanned from left to right. Okay, so this is left and this is right. If your function is increasing upwards when you go from left to right, then it's increasing. Okay? And if it's going down from left to right, then it's decreasing. Okay? That's slope. This is a function, okay? So a line is just a function. Oh yeah, okay. So the first type of functions we're going to be talking about are linear functions. Okay. And linear functions have the form of y equals to mx plus b. Okay. And this is called slope-intercept form. Can you tell me why it's called slope-intercept form? Can you close the last there? Yeah. There's literally, okay. So slope-intercept form, okay? So why is it called slope-intercept form? No. Because that's y is equal to mx plus b. That's the equation of a line. It's the equation of a line, yeah, but why is this called slope-intercept form? What do we have here? What can we easily tell from here? The slope. Yeah, what's the slope? Is the m and the b is the y-intercept. Yes, okay, so this is the slope and that's the intercept. Okay, now the second form we can write a linear function in is ax plus by plus c. Okay, and you know what this is called? Standard form? Yeah, that's called standard form. Okay, and although both are equivalent, they are graphed using different methods. Okay, so general properties of linear functions. So the general properties, I should just write general properties here. Okay, so I'm just gonna write forms. Okay, so these are the forms. Okay, now general properties. Never good enough. Okay, so general properties. So what's a domain of a function? Do you know what domain means? No. Have you heard of it before? No. Okay, so a domain of a function is basically all the x values that exist on the function. Okay, and this is a notation we use for domains. So we make a curly bracket, and then we write x. Okay, now all the domains will always have that curly bracket x and a straight line. Okay, and then in this case, a line will, what are the x values for a line? Okay, so if this is a line, for example, Okay, and it's going to like positive infinity and negative infinity, the axis, right? And the line just keeps on going forever. So what x values will it have?
1, 2, 3, 4, 5, 6, 7.
It will have all possible x values, right? Do you see that on the line you can have the function for every single x value, right? Right? So that's why the domain of a linear function is x is the element of the real numbers, like that. Okay, so you basically just write an x, you put element, and then you have this two like lines and an r means real numbers. Okay, so that's the domain. That's the domain of a linear function, okay? Now we want to talk about the range. Okay, so if domain was all the x values, what would range be? What will the range be? What axes do we have? We have the x-axis and the y-axis.
Yeah. I mean, why are we writing? What's the point of writing this?
When we want to like analyze functions, we want to know like their domains and ranges. It tells us more about the function. Okay, the range has to do with y. Okay, and a line, since it's going like upwards, it has all the y values, right? It can pass through all y values. So y is also the element of the real numbers. Right? Real numbers just means like any integer, negative number, positive number, decimal, like real numbers consist of all numbers, okay? Including 0, of course, right? So that's that. Okay, and then you can obviously tell me this. A linear function is increasing if the slope is positive or negative. An increasing function has what slope?
Positive or negative?
Yeah, which one?
Positive.
Positive. And if the function is decreasing, the slope will be negative. Okay, good. Now I'm gonna write down two functions on the same grid. Okay. Okay, so I should get a piece of paper that you can write stuff to.
Okay. Can I write on my tablet?
Yeah. No one has to really see it, but just so that you can like do it yourself, right?
Okay. Teacher. 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 Teacher.
Okay, so I'm just gonna erase this actually.
Teacher.
So I'm gonna move this over here.
Teacher. I can't see your screen. Can you zoom in?
Yeah, okay, so what I'm gonna do, I'm gonna give you problem 1. Okay, and that's to sketch each pair of lines on the same grid. So don't copy anything I wrote.
Wow.
No, I'm gonna give you these notes.
Not even domain.
No, you're not writing down anything. You are going to only sketch each pair of lines on the graph. Okay, so problem 1 is so I want you to sketch each pair of lines. On the same grid. Okay, so first one we're going to do is y is equal to 2 over 3x plus 1, and y is equal to negative 3 over 4x minus 5.
Mom, what did you write underneath it? That's B?
That's a y. That's a 4.
Is this B, number B? A, this is B.
No. Each pair of lines on the same grid.
Each pair.
Okay, that's why I'm giving you two equations. First, you're going to, on the same like xy grid, you're going to sketch the lines, okay?
Okay, so I don't know how to do it when it's a fraction.
That's the slope.
Yeah. So how do we determine? I don't know how to do this.
think, try something. You have to give me some answer, then we'll take it up together.
Okay.
Are you done?
Okay.
Okay, so now let's take it up together, okay? So for the first one, okay, this is a line. So it has, so we know that when x equals to 0, y, oh, that's good. Okay, so when x is equal to 0, right, this will all go to 0 and we'll just be left with 1, right? So when x equals to 0, y equals to 1. So you can just plot that point right there, okay? And then just plug in 0 into your equation. 2/3 times 0, anything times 0 will become 0, and you're just left with 1.
Why did you do that?
So that we have the first point on our line.
This is the rule, right?
That's the, Aisha, what does 1 mean here? It's the y-intercept. The y-intercept is 1. Right? Y-intercept is always when x equals to 0.
How do you know?
The y-intercept, this is the y-axis, this is the x-axis, right? X, right? So when x is equal to 0, y is equal to whatever, like at x equals to 0, wherever something passes a y-axis, that's the y-intercept. That's what it means.
X is equal to 0, y is equal to 0.
When x, I should look at the equation. Y is equal to 2/3 x plus 1. Should I write it again here? Y is equal to 2/3 x plus 1. What happens when you sub in x equals to 0?
Why would you do that?
So that you know the y-intercept of the line. How else do you graph a line? You need the y-intercept and you need the slope.
Why is y?
Y is equal to 1 because this x, if it's 0, 2/3 times 0 is 0. 2/3 times 0. What's 2/3 times 0?
0.
Right? It equals to 0. So what are you left with? Just the 1. Y is equal to 1. Do you see that?
Yeah.
Okay. So we're gonna plot that on a graph. Okay, don't change anything you do in your line yet. Yeah, I'm gonna look at yours and tell you exactly why you're wrong. But first, look at the answer. No, put your pen down. Okay.
So what is the answer?
So now we have to look at the slope. Okay, so this is the rise and this is the run. Okay, so if it's a fraction, then you always know that you have rise over run. So you're gonna rise 2, 1, 2, and you're gonna run 3. 1, 2, 3. Okay? So let me not write it because then it's gonna look messy. Okay, but if you can see my pointer, 1, 2, 1, 2, 3. Okay, so your point will be at 3, 3. Okay, same, your slope over here is also rise is 2. We're gonna go 1, 2. Okay, and our run is 3. So 1, 2, 3. Okay, we're gonna be right over here. Okay, do you see why?
I got the answer.
Okay, and then same over here. We're gonna go down 1, 2, and we're gonna go 1, 2, 3. Okay, anyways, and then if you keep adding your dots, then you're gonna get a line like this. And obviously, it does not fit properly.
It's a curve.
It's not a curve. It's the equation of a line. It's the equation of a line. You can't have a curve.
Because mine wasn't very straight either. I had to make it straight by hand.
Wait 1 second. Like that. You can obviously see that it's a line. It's just that my points are like a little bit off. Okay, let's just make them bigger points so that they just go through properly. Okay. Now if you see, ta-da. Okay, you can see that. It's obviously the equation of a line. It has to be a line. Okay, no curves here. Next. So your first line has to look like this. What does your second line look like? So wait, tell me, what's the first thing you did to graph your second line?
I put at -5.
Okay, good. So you put a dot at -5 because that's your y-intercept.
I went 3 down and 4 left.
Good. 3 down and 4. Why left?
Because it's minus.
No, the minus is only for down. So if it's -3, you're gonna go down 3, and you're gonna go 4 to right. Here. Okay, and then if you wanted to go, let's say you can choose, right? You can either do, you can either put the negative upper or niche, but you have to only put it in one place. So you can go also 3 up. So if you went 1, 2, 3 up, then you have to go 4 left. So 1, 2, 3, 4, like here.
What?
So once it's negative, you have to like do only one of them would go down or left.
So it's the top one, right? That goes to that. That goes up, right?
Okay, no, look over here what's happening, okay? So if it's 3/4, if your fraction for the slope is -3/4, okay? The -3, this will mean go down. So down 3, and right 4, okay? But what if you just but this is equivalent. This is the same, equivalent. Okay, what does this mean?
-4 to the
No, what does it mean?
left.
Yeah, left 4. And what does the 3 mean?
Right. Up.
Yeah. Okay, this one means up. Okay, so see, what are we doing here? We're going 3 down. So 1, 2, 3, 3 down, and 4 to the right. 1, 2, 3, 4. Okay? Okay, and then over here, what did we do? We did 3 up. So 1, 2, 3, and we did 4 to the left. 1, 2, 3, 4. Do you see that? Okay, it's all the same line. Okay, so that's why they're equivalent, because they all make the same slope, right? The slope here is the same as the slope here. Do you understand that? Yeah? Okay, now tell me, what is the point of intersection? So make sure, so now fix your graphs that you made in your tablet. Okay, fix your graph. And tell me, what is the point of intersection?
One, 2, 3, 1. -3, -1.
I don't think so. Wait, oh, because my point of intersection could be wrong. But I'm pretty sure it's -4, -3. You didn't even label your axes, right? X here, right? Y here. Okay, good. And also, normally you should like label like your things. But anyways, like you don't have to label it that much, but like I'm just saying that. If you have like a point, then you would label it pretty much. Anyways, it's fine because we don't have to worry about that. They just want us to sketch the pair. Okay? Okay, how about this one? Okay, so now it's part B. I don't know, but I have to pay it, so we have to do quickly. Okay, listen. So y is equal to 2 and x is equal to -3. Graph those lines.
How?
And graph them.
But I'm not given an equation.
Yes, those are the equations. If y is always 2, y is always equal to 2, then how would the line look?
My tablet fine. Here and -3 here. So like this.
Okay, so make sure you always label your x and y axes. Okay, and then if y is equal to 2, so this is y equals to 2, and no matter what x is, like there's no even x term in this equation. It's just y is equal to 2, right? So whenever you have a y equals, we know it's going to be a horizontal line. Okay, if it's just y equals to a number, we know it's a horizontal line. Okay, and the line will look like this. What? No. Y equals something, a number is always a horizontal line. Okay, and how about x equals to a number? What will that give us? Yeah. Okay, so that will give us a vertical line. And where will the vertical line hit the x-axis? Okay, so it's going to look like that.
Oh.
Okay. So wait, I'm just move it so that it actually goes in -3, right? Like that. Okay, now tell me, where's the point of intersection here of the two lines?
1, 2, 3, -3, and +3.
No, look at it.
+2.
Yeah. Okay, good. Next. Okay, so now I shift the equation of the line. Okay, so wait, what's the equation? Oh, we didn't talk about slope. Okay. So Aisha, what is
Oh no, Aisha.
m equals 2?
But actually,
M so the slope of a straight line, okay, can be found by any 2 points. Okay. And it's basically the change in y over the change in x. Okay.
When?
It's rise over run.
Oh yeah.
And what does that mean?
Y2
The change in y.
over x2 minus x1.
Yeah, y2 minus y1 over x2 minus x1. Okay, so you always have to remember that. Okay, so given the 1 point and another point, you can just write down the equation of a line. And I'm going to show you another way. So there's 2 different methods. Okay, so I'm going to write equation of a line. Okay, given like, okay, so there are 2 ways. So one is y minus y1 is equal to mx minus x1. Okay,
How did you write that?
that is, this is a preferred method, okay, because like in calculus and bigger years, you're gonna have to write the equation of a line like this, okay? But another way you can write it,
Why did I B?
that's this one, okay? So y is equal to mx plus b, okay? And for this one, you need, so using slope and 1 point.
So for the first one, they both mean the same thing, right? The two equations.
Yeah, they're both the same. See, because it's y1, if you bring it to the other side, it becomes our plus b. along with our mx1. Anyway, so using point P x1, x1, y1. Okay, good job. Okay, so this is the equation of a line. Okay, so now that's good. Okay, I'm gonna give you this problem. So problem 2.
Is that the last problem for the day?
No,
Please, it's 8 o'clock.
no.
Okay, Google.
Problem 2, okay? So find the equation.
Alright, 20 minutes.
Did you paint them, Asya?
No.
Okay,
Let's-
okay, wait, let me just write down the
Take a
question.
prayer break.
Find the equation of a line through the points 2, 3, and negative 5, 10 in both standard and slope-intercept forms.
Okay, well, you write the question, I go, and then I'll ask the question.
Oh, wait, how do I pause this?
Don't pause it.
Wait, how do I pause it? Okay, guys, so we're just going to take a prayer break and we'll be back.
Get off your phone, you ugly little
That's why the mic's on.
Why is the mic on?
It was on. We left it there.
Why would it be on? Oh shoot.
Oh.
Anyways, okay, now I'm gonna unrecord the recording, okay? And get rid of the
Sorry, I like it. It seems like it's like a laugh.
no. Pay attention to what I'm saying. Close your phone.
What do you mean? This is all going on. Woo!
Now put a 20-minute timer.
Okay, Google. Banana.
Ready? Okay, I'm gonna pause my recording now. Ready? Okay. Okay, guys. So I just came back from our break, and here's a problem I want Aisha to solve. So find the equation of a line through the points 2, 3, and 5, 10 in both standard and slope-intercept form.
Okay, so I think the first thing you should do. I think what needs to be done is you need to plot the points.
Okay, let me actually tell you the steps because you're gonna waste a lot of time. Okay, so one is that you want to solve for the slope.
For both the points.
You use both points to solve for slope y2 minus y1 over x2 minus x1. Okay, this is x1, y1, and this is x2, y2.
The answer is -1. It's 7 over -7.
So yeah, -1 is your slope. Okay. Now step 2 is to put into an equation. Okay, so I want you to try the y minus y1 equals to mx minus x1 way. Okay, so you're gonna put in any point. So do you want to use 2, 3 or -5, 10? Okay, so you can use 2, 3. Okay, and you're gonna plug it into this formula. Okay, where x1 and y1. Okay. And you already know your m, so make sure you put in your m too.
B is 55. So the equation is y is equal to -1 x plus 5. Ta-da!
Okay. So now the question says in both standard and slope-intercept form. So you have your slope-intercept form. So how will you convert this into standard form?
F plus B, F plus B.
Yes.
The
Equals to 0. Equals to 0 is your key feature here.
I don't know.
Okay, so how about you try bringing everything to one side?
Everything is on one side.
No. You want,
Oh.
okay, how about you do this? Why don't you bring all of this to this side, okay? So y plus x minus 5 is equal to 0. You want your equation to equal to 0, not y.
Okay.
Okay? So what do you get?
Y plus X minus 5 is 0.
Okay, good. That's your standard form. Okay? And if you were, and then also remember that if you used another point here, you'll get the same answer, right? Because it's the same line, right? The line goes through both these points. The equation of the line would be the same. Does that make sense?
Yeah.
Okay, now we're gonna take it a little step further. This is still stuff you know, like this is all stuff that you should have learned already, right? This is mostly a review lesson, okay? Now find the equation of a line. So this is find the equation. Is it a good pace or should I go faster?
Faster.
Okay, through the point. Okay, so you want to find the equation of a line through the point 1, 2. Okay, and then we want to find it parallel to the line 3x plus 4y plus 5 equals to 0. Okay, so first do A and then I'll give you B. Okay, so the equation of the line goes through this point 1, 2, and we have to make it parallel to the line 3x plus 4y plus 5. Okay,
I
so
never learned how to make something parallel to that.
you didn't learn?
No.
Are you sure?
I'm sorry.
Okay, so parallel means that it has the same slope. Okay, so I'm doing another color so you remember. So parallel means same slope. Okay, so if this line and this line are on some axes, this will have a different y-intercept, this will have a different y-intercept, but the slope will be the same. Do you see? So see, any line you draw parallel to it will have the same slope, but
Yeah,
different y-intercept.
I get.
Okay? Okay, so if you need to find the same slope of this line, so what's the first thing you would do?
Y is equal to mx plus b. Okay, how are we gonna find that? We're going to change it to standard form. We're gonna change it to y-intercept form. Hello, teacher.
Yeah?
Hi, teacher. Hi.
Yeah? What happened? Why are you not working?
Hi, teacher.
Aisha?
Hi.
Aisha, did you find the slope of this line?
Oh, 4.
Are you good? Okay, wait, I don't know. I didn't. The slope is.
How do you find it?
The slope is not 4. Aisha, what is this form called?
A standard. So I asked at the beginning. You have to change it to 1.
Yes, because how else would you know the M?
I don't know how to change it.
Okay, so basically from standard form to slope intercept form. Okay, you want to isolate for y. Okay. Okay, what's your M?
I don't know how to isolate the y.
You will basically bring your y, your 4y to the other side. So it's going to become negative 4y equals to 3x plus 5. Then how do you get rid of the negative 4, Aisha? You're going to divide both sides by negative 4. And then that.
Y is equal to 3 over negative 4x plus 5 over negative 4.
Okay, Aisha, your negative should always be outside. Like if it's a fraction, negative 3 over 4.
The denominator.
No, bring it outside. When you write down an equation, you have to write the negative just right outside the fraction, right? Because it's negative 3 over 4. Do you understand?
So I'm making the negative sign very in the middle.
And what would so it'll be, what's the whole equation? Read it to me.
The whole equation is negative 3 over 4 minus negative 5 over 4.
Yes. Okay, remember that if it's like a plus 5 divided by negative 4 will just give us negative 5 over 4.
Sure.
Okay? Can you do that much?
Yes.
Okay, now tell me, so for part B, if you don't know what parallel means, I couldn't even imagine you would know what perpendicular means.
I know what perpendicular means.
What does perpendicular mean?
It means like this, and you have a right triangle.
No, what does that mean in terms of slope?
Right. I don't know.
What does that mean in terms of slope? How would you solve this?
There is no slope.
Perpendicular to the line 3x plus 4y plus 5 is equal to 0. You want to find the equation of a line through the point
Idea.
perpendicular to this line.
Yeah, instead of working on grade 11 math, we should just do review grade 10 math again. Because honestly, I did it online, and who knows how good I was at it. I wasn't bad at all. So.
Yeah, I can tell. No, I think we're gonna do IXL because you need a lot. I feel like the concepts are not that bad. You just need a lot of practice.
True.
But this is all review of grade 11. You know, this is nothing new. You should have known this already.
Well.
This is, look, the lesson's name is reviewing functions.
But we never did functions.
Yes, you did. You learned the equation of a line. You learned quadratic stuff in grade 11. Then what is it, Aisha?
It's the lines.
They're obviously functions.
Teacher,
You don't know the definition of a function, but I'm just saying that, like, you did learn, like, what this is. You just didn't know it's called. Aisha, solve B, part B.
The part B. How do I do that?
So perpendicular means that that means it's a negative reciprocal of the slope. Okay, so I'll just write this here. Perpendicular means negative reciprocal.
Okay. Damn, negative reciprocal. So if we find the slope, we found the slope already, right?
Yeah.
So all we have to do is negative reciprocal it.
Yeah.
4 over 3. 4 over 3 is the slope.
Yeah. Okay, next. Then you do the same thing as last time. We just plug in the point in the equation.
Doing this.
Yeah, I hope so.
A little bit, but I'm so small, you see. What's next?
Girl, you're in grade 11. You know what that means? Like, you should literally be preparing for universities now.
Okay.
Okay, so what's the equation of our line, Aisha? Aisha, what's the equation of our line?
Y is equal to 4 over 3 x plus 5.
No, where does plus 5 come from?
It's in the last one.
No, Aisha, you have to solve for the y-intercept every time. It's not the same.
Okay, LOL.
No, no, we have to put no here. No.
No.
Do not assume the y-intercept is the same. As before, okay? You have to solve. Must solve.
Okay, so he's so emotional. Okay. So, but how do we do that?
You know your point is 1, 2. You know your slope
How do you know your point is 1, 2?
is given in the question.
Oh, okay. I know what to do. This will give you, if you have to times these two together, right? You have to times these two together.
Why are you going to be timesing them?
This will isolate everything except b.
No, the plus b, not multiplied by b.
Oh, sorry. I forgot.
You have to bring everything to one side.
It's like 2 minus 4. But I have to do a same denominator. So 6 minus 4 is 2 over 3. Is b. B is 2 over 3.
Okay, now write the equation of your line.
Y is equal to 4 over 3 x plus 2 over 3. Isn't that just astronomical?
Okay, let me see. There are a lot of functions that you need to know, prerequisites, in order to do anything else.
Hope I don't get Miss Kachuk. She's really strict.
I hope you get her.
I
I heard
see.
she's the best.
I heard Miss Ben, she's the best, but Miss Benelli is the nicest. Although she won't teach you properly. But that's okay.
No. Miss Kachuk is the teacher.
Miss Benelli
Okay,
is the
now let's go over some definitions because you're really bothering me right now. I don't want to give you more stuff too.
I'm bothering teacher.
Okay.
Teacher is being mad.
Okay. Wait, so what's your final answer for this?
Y equals to 4 over 3 x plus 2 over 3.
Yeah, good job.
Okay.
Okay, now write down these definitions.
Look at the teacher.
Okay, Aisha, so for any given function, so let's first talk what is a function, okay?
What is the function?
So function is basically a relation. Okay, you're gonna be relating two variables x and y. Okay, so a function is a relation where
Function is a relation.
a function is a relation.
Well, so why do we say
Write it nicely, but no, write it nicely so you can read it if you ever have to. Write it nicely. A relation where each value.
I'm working right now. I'll rewrite it when my free spare time.
Variable. Why am I writing it? I should make you copy down. Why am I even bothering wasting my time?
Sorry.
No, you just don't want. You don't care. I'm erasing this. In your own time, write this down. The definition. No, you don't like them. Then you have to be serious. Okay? Okay, so copy down. How much did you write already?
Function is a relation.
Okay. So function is a relation where each value of the independent variable
Correspondence
I just realized this is so much better. This way. How come you didn't tell me that before?
Sorry, Mom. I could tell you to do it, but I didn't know that. I promise I read after class next. I can't read right now. I'm going to stitching and pain.
Pain from what?
I'm laughing.
Okay, listen, range. The range is the set of all values.
So it doesn't understand. So the relation where each of the independent value variable,
Oh, I should tell you what a relation is.
a relation is a relation.
Yeah, and you don't know what a relation
A
is.
relation where each value of the independent variable corresponds with one value of a dependent. So x is the dependent variable and y is the independent variable.
Yeah. Okay, so a function is a relation where the value of each independent variable corresponds with only one value of the dependent variable. Okay, so that means for every x value, we only have one y value. Okay, now so then examples of functions are like the equation of a line. Okay, because so a function has to pass the horizontal line test, which you don't know yet, but I'm just going to mention it right now. Sorry, passes vertical line test.
Did you get homework? We have 5 minutes left.
Okay, wait. 5 minutes plenty. Okay, so passes a vertical line test. That means for every vertical line you can draw, for every x value, there's only one y value, right? So we only touch the function once. Okay, so a line is a function. Okay, a line is a function. Okay, how about over here? Does a parabola pass the vertical line test?
No.
Why? For every x value, there's only one y value.
Oh, so if I don't curve.
No, it can still curve. That's fine. It's still a function. Okay. How about if the function looks like this? How if the function looks like this?
No.
Why?
Because it's not a curve, nor.
No. We're not talking about it's a curve or not. We're talking about the definition of a function.
Yes, it's a function.
Is an example of a function. Okay, a function can be a lot of things. It doesn't just have to be a line or a parabola.
And you know those school things that you do in university?
Wait, listen, this is a function. See, because for every vertical line, it only touches the function once.
What about the scribbling you do in university? So is that also a function?
What's scribbling?
That you scribble on the graph like this.
Show me.
Like scribble like that.
That's not a function. No. What does the definition of a function say?
Where the independent
For every
variable-
x value, there's only one y value. Okay? You only get one y value. Okay, now let me show you something that's not a function. That scribbly thingy you drew, that's not a function. Okay, because see, for if x equals to 1, see, if you draw a vertical line at x equals to 1, it passes it more than once. There's two y values for an x value. This is not a function.
Thank you.
Okay, this is not a function. Aisha, is this a function?
But there is a y value.
but there's two y values. We need one y value
Why is it two?
because this is not a function
Why is it two y value?
on a circle because that's how a circle is drawn. Okay, how about this circle? Is it a function?
No,
Why?
it's two y value.
Yeah, for every x value, there's two y values. Okay? So do you understand what makes a function?
Yes, teacher.
Okay, now let me show you more functions.
Yes,
What?
teacher.
How about this one? Is this a function?
For real?
Is this a function?
Yeah. No.
Yes. Yes.
Yeah.
Because for every x value, you only have one y value. X
Here,
value have
But
y
look
value.
here. There's one.
X value, there's only one y
But
value.
look here. There's one and there's one.
They're different x values. This is negative x value, this is a positive x value. These are different x values.
Wow. Look, I can read.
No. Let me show you another function. Is this Aisha? Look,
Yes,
is this a function?
yes, teacher.
Why?
Because for every x value, there's a y value.
Yes. Okay. Is this a function?
Yes, teacher.
Wait, no, I was trying to not make it a function. So you would have been wrong.
No, teacher.
Is this a function?
No, teacher.
Why?
Because there's Actually, it is a function.
No, for every x value, let's say x is equal to 2, we have
Two y.
more than one y value, so it's not a function.
Okay, teacher, can you give homework?
No, what's the relation?
A relation is a set of ordered pairs.
What's an ordered pair?
An ordered pair.
What's an ordered pair? Can you write one down for me, an example?
Ordered pair. Oh, like this example. There's a 2, so there's a pair.
No. If you don't know what it is, tell me. Okay, don't make random guesses.
Time to take a break.
No break. Listen.
Okay.
Ordered pair, it's just any coordinate, like 2, 3, or 7, 8. Okay, we have some x, we have some y. It's a pair of numbers. That's an ordered pair. Okay, like for a line, we can have like 1, 1. We can have like 2, 2,
So
right?
coordinates.
Like any coordinate, yeah. Okay, now values of the independent variable x are paired values of dependent variable. If you just read the rest of the sentence, you would have known what an ordered pair is. Anyways, moving on. Okay, we can do range and domain tomorrow, but let me give you homework on IXL now. Okay, so do you want to do grade 10 practice? Actually, maybe you should grade 9 practice.
I want to do a grade 4 practice.
Do you want to do grade 10 practice? Do you want to do grade 11 practice?
Grade 10.
Grade 10? Okay. So here,
Please, Mom.
listen.
Please, teacher.
Okay, you want to get through all of this, at least most of it. Actually, no, do all of it.
Listen to a recording.
Yeah, you. Okay, look, you have to do L 1, 2, 3, 4, 5, 6, and 7. Actually, no, you have to do all of them. You have to do up till.
7, 8, 9, 10.
Okay, fine, do half of them. Do until 12. Okay? So we're gonna do 1,
Okay.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then tomorrow's homework will be 13 to 26. L 13 to 26.
But each one will take an hour. So this will take me the whole day.
Yeah, exactly.
I'm not a baby. I don't want to do it.
No, do it. If you know it, then you should be able to get
But
the
I don't
100%
know it.
easily.
You just tell me to get it.
No, you do. I just told you today. We talked about it. Okay, now write down. This is today's homework. That's tomorrow's homework, right? L 14 to L 26. 26.
There's 2.
Where's the L? Okay, so we can talk about, so this, right, so do you see this is linear functions, right? Complete a graph, whichever ones are kind of irrelevant, you can skip only 3. Okay, so you only have permission to skip 3.
Only 3.
Okay, but you have to do all the rest of them.
What are
Then-
you gonna do if I don't do it?
Well, I'm gonna scream at you. I'm gonna punch you. I'm gonna
Don't.
get physical. Just kidding. Just kidding.
Are
I'm
you
just kidding.
This is gonna take a video.
I'm just kidding. Okay. Systems of linear equations.
Mom's gonna be. Oh
Okay.
my gosh! I literally have live proof that you.
Do you remember systems of linear equations? Do you remember?
Yeah, I don't remember what to do in it, but I remember the name.
Okay, so we'll do these next day.
Okay,
Okay.
see you, teacher.
So, Jazakallah for tuning in, everybody. Aisha.
No
And
one's
we will
gonna
see
watch
you
this.
tomorrow. Allah Hafiz.
Bye.
See ya, teacher.